watch in person as Sundar and Demis laid out an ambitious vision for the future of software. And apparently, that future is Gemini hiding inside of every product like the microplastics in your bloodstream. The roadmap is basically take Gemini, append a noun to it, and ship it. Gemini Spark, Gemini Omni, Gemini Flow, and the list goes on. They're calling it the agentic Gemini era. The search is now an AI agent, Gmail is an AI agent, Android is an AI agent, your glasses are an AI agent, and as I watched the keynote, I realized something. Google is no longer trying to organize the world's information with blue hyperlinks, because search engines are now an archaic technology. Instead, Google is trying to become the interface to reality itself, before Anthropic and OpenAI create better realities. But luckily, Google I/O wasn't all about AI. I didn't see any updates about Angular, but I did come across a new awesome web API that every web developer should know about. In today's video, we'll break down everything you missed at Google I/O. It is May 22nd, 2026, and you're watching the Code Report. Whether you love it or hate it, one thing is undeniably impressive about Google, and that's its ability to scale. Not only is it serving its core products to billions of daily active users, but in the last 2 years, they've gone from serving 9.7 trillion tokens per month to a staggering 3.2 quadrillion tokens per month, and that number is going to continue accelerating. In addition, Alphabet's capital expenditures have exploded, building new infrastructure to support all these stupid AI images you guys create with Nano Banana.
You ever see a pug dressed like an accountant?
No.
You wanna?
One thing that makes this massive scale possible is Google's TPU chip, or Tensor Processing Unit. I remember being amazed seeing a TPU at my first Google I/O back in 2018, but this week they announced they're splitting these chips into two distinct jobs: training and inference, with the TPU-T and TPU-I. In other words, Google now has one chip that's optimized to teach a robot how to think, and another chip that's optimized for it to hallucinate search results on a global scale. The headline announcement at Google I/O, though, was Gemini Omni, a model that takes any input, like text, video, and sound, and produces any output. Demis Hassabis, who might be the smartest guy at Google, appears to be fully world-modeled pilled, because models like this don't just generate pixels anymore. They understand language, physics, motion, and everything else in your world just well enough to simulate reality on demand. But along with this new model comes an entirely new design system for the Gemini app called Neural Expressive. At first glance, the UI looks like a simple glow-up with new icons and better gradients, but what's unique about it is that it's optimized for generating UI elements on demand, like diagrams, timelines, and even mini-apps that didn't exist before your prompt. Now, when it comes to Google's core large language models, they released Gemini Flash 3.5, which is not the big brain model, but the fast model. According to the Trust Me Bro benchmarks, it performs nearly on par with Opus 4.7 and GPT 5.5, but runs at a much faster speed. Like, if we look at this Trust Me Bro diagram, we see that Flash is entirely in a quadrant of its own in terms of speed and intelligence. However, it's important to remember that this is not their top tier model. Gemini 3.5 Pro is still under wraps and not expected to release until later this summer, which was very disappointing to a lot of people on the internet. Speaking of disappointment though, not everybody was happy with the new direction of Google's Anti-Gravity IDE. Anti-Gravity was formerly known as Windsurf and was a VS Code fork for AI coding just like Cursor. And once again following in the footsteps of Cursor, its latest version looks like an OpenAI Codex clone that's more focused on managing agents than writing code. Old school programmers might not be happy with this change, but the live demo was pretty badass. They used the tool to build a complete operating system from scratch, which took like 12 hours and billions of tokens. But then they tried to play Doom on it, and it failed due to missing drivers. However, live on stage, they had Gemini code up those drivers, and within a few seconds, Doom was up and running. The most impressive part was just the sheer speed at which this thing could spit out tokens. But the speed is not the only thing increasing. The price of Gemini 3.5 Flash is 3 times more than the previous version, and 30 times more than Gemini 1.5 Flash. It's still a lot cheaper than Claude, but not nearly as cheap as it used to be. Almost everything at I/O involved AI in one way or another, but if you're a web developer, one cool thing you should know about in Chrome is the HTML and Canvas API, which, as the name implies, allows you to use HTML elements directly in a canvas now.
Those are native HTML elements rendered into the canvas.
Woo!
That means you can build highly interactive UIs where you control every pixel with tools like WebGL and WebGPU, while simultaneously using HTML for your more basic UI elements. The only question is which AI coding model should you use to work with this API? Well, that's why you need to know about Emergent, the sponsor of today's video. Everyone's switching between 5 different coding models these days, but we still need something to help us ship full stack applications that actually work. And that's exactly where Emergent can help. Right now, I'm using it to build a pull request review dashboard where I can paste in a GitHub link and get an AI summary of all the changes and risks per repo. You still start with a prompt, but instead of one LLM guessing how to build everything, Emergent spins up specialized agents to work on your app's front end, back end, database, testing, and deployment all in parallel. You also don't need to mess with any Supabase wiring or Express boilerplate because that one prompt sets up your app's database, auth, and APIs. If you're really into self-torture, feel free to keep scaffolding this stuff by hand, or you could just describe the tool you want and let Emergent's agent swarm build it all for you. Try it out for free at the link below. This has been the Code Report. Thanks for watching, and I will see you in the next one.
Okay, that was the Fireshow video. Now let's get started on what we were doing last week. Let me share my screen. Okay, let me know if you guys can't see it. So we're on 12, I believe. So we did dataset. We did decision tree, and now we need to do main.py. And that's it. Okay. So basically we're doing a zoo animal decision tree classifier. So this AI is gonna take an input for like the number of legs, if the animal is hairy, etc., and then go through the decision tree to decide what kind of animal it is. Okay. Let me give you guys the live share links. That's the live share link. Here's the GitHub link. And project 12. Okay. So first person is Adam. When you're ready, can you share your screen? Let me actually enable share for everyone. Now you should be able to share your screen. So just open up the main PY in project 12. Are you saying something? You're unmuted, but I can't hear you. Okay. While we wait, Albert, can you share your screen? Albert? Yeah, Adam, your mic is on, but I can't hear you. If you're saying something, you can just type it in the chat. Okay, while we wait on those two, can Charlie share screen? Thank you, Charlie. Accepted it. Okay. So first thing we're gonna do is create a dictionary on line 5. So go to line 5, and you're gonna create a mapping of the IDs and and the classifications that you can get. So like a mammal or a bird or etc. So what you're gonna do is all caps class underscore mapping equals a diction. Yep, great job. Enter. Yep. So the keys are gonna be string one. So yeah, that works too. Actually, does it? Let's just play it safe and then do double quotation. I'm not really sure if it works. And then colon, and then it's gonna be mammal, mammal. Yep. And then comma after the quotation. Second one is gonna be, yep, good job, bird. Third is reptile. Fourth is fish. We're gonna do 7 of these. Fish. Yep. Amphibian is 5. Yay, good job. Two more. Bug and invertebrate. Great job. Now, okay. Let's go down to classify. So it's going to be the second function. That one's a bit less. So basically, if the node is instance of a leaf, so if there's a tree, the leaf is the last node. If it is a leaf, then we want to return the stored prediction inside the dictionary. And we want to see if the feature matches. If it does, then we want to recursively slide down the tree until we reach a leaf branch. So what you're going to do is if is instance. So what this does is it checks if some variable is a type. So if you do like is one is an int, then it checks if it is an integer, if one is an instance of an int. Does that make sense? So what you're gonna do is, yeah, node, comma, great job. Decision underscore tree dot leaf. Yeah, great job. Great job. And then no need for that. It's gonna be just a variable. So and then colon, enter return. Oh, my bad. Let me pull down for you. Return node dot predictions. Great job. Yeah, no, not a function. Enter backspace. Yep. If node dot question dot match, and that's a function, and we pass in row. Then we want to do return classify. So this is the recursive part. Row, comma, node dot true branch. True underscore branch. Great job. Now else, and then return classify. Row, comma, node dot false branch. Great job, Charlie. Great job. And you can stop sharing. Okay. Oh, Adam, I think he's resetting his mic or something. Uh, yeah, Adam's back. Okay, while we wait for him, Albert, can you share your screen? Oh, okay. Adam, can you share your screen now, or maybe I'll just give you some more time. So just yeah. Okay. Yo, right. Okay. Albert, take your time. You don't even need to share. But yeah, let me know if you can share or something later. Oh, okay. Uh, so I guess okay. Yeah, great job. Git pull the main.py, main.py. Yep. So okay, give me some time. Git git commit. Uh, uh, can you pull again? Git pull again. Okay. So there's the classify and the class mapping. So let's do main. So actually, let's do print tree. So yeah, delete that one. So basically, this is printing the tree. So you're going to recursively go down the tree, print it out, and traverse through it, as well as if it's a leaf node, then you want to stop and go back. Anyways, if is instance. So if the current node is a leaf, then we want to do enter, enter, but delete that and then do readable prediction. Actually, yeah, delete that. Yeah, up to there. Readable underscore predictions equals, is that a dictionary? Yeah. Dictionary of class mapping dot get. And delete the square bracket and key. Get delete key and then do yep. And then the argument is gonna be K, comma, K. Yeah, so two instead of one key. And then we're gonna do value for K in node prediction dot items. Yeah. Why is it showing? What's it saying under key? Oh, because then you're gonna have to do get key, comma key. It's because it's not. So instead of K, comma K, you gotta do key, comma key. Yep. And next line is print spacing. Yeah. So that's gonna be the tree. And then we want to return after that. Return after the print. Enter. No else statement. No else. No else. Feature name equals feature names. The question called if feature names else. Yep, I think that's good. You can tab it. So basically, if the current column is in feature names, no, if the current feature names, then we want to print out or set feature names node column, or else we want to print the current feature, which is that column, and set it to feature name. Next, we want to print that. So it's going to be the label or the name. And then enter. You're going to do print spacing yes or true. Enter. You're going to do print tree. So this is the recursive part where you're going down the true branch. And then same thing for the false branches. So do enter false branch. So you're going to do both branches. So you guys get what the true and false means, right? So it's basically a decision classifier, right? So it's going through that tree and saying, okay, is this a amphibian? Is this a bird? True or false? And it goes down, right? So this is a 2 to the power of n tree. Every decision made only has two choices at every node-ish, right? That's why we're going through the tree, true side and the false side. You can stop sharing. Adam, can you share your screen or? Adam, are you able to share your screen?
Okay.
Also, hi, Kaden. We're working on Project 12, so let me give you the link. Yeah, no worries, Kaden. That's the live share. This is the GitHub. Let me accept you. Yep, guest user. Okay, accepted. So you're gonna want to do main, the last function. So delete pass. So basically, we made the three functions. Now we want to use it. So you're gonna call the database module function, which pulls in the fresh data and the headers from the web. And then you want to build it, that decision tree. And then you want to construct a custom feature list and run a test animal through the classification to see if it works. So let's first just print, I guess, print, and then you're printing out a string. The string is going to be fetching live zoo dataset from the web. Good. Next line, feature headers, which is Feature, feature, Fe, yeah, underscore headers. Uh, D instead of TH. Uh, H instead of V. Okay, wait. Header as in like, yeah, comma, training data, training data, underscore data. Yeah. Equals dataset dot load online data. Yeah. Enter. Enter. So when you click enter, it will autocomplete. Okay. I think it's tab actually. I'm not sure. But yeah, delete that. What's load enter? Okay. Was it tab or enter?
Tab.
Okay. Yeah. So tab and then that's the function. So do load online data circle bracket. No, like before the previous line. No, line 43 at the end. Sorry, delete that thing we just did. No, not that. Yes, yes. And then do circle bracket. No if, no space. No if.
What?
Delete the if. Yes. Okay. Next line. No, no. Delete the if. No need for the if. No, no. Delete the if. We only need the circle bracket. Yes, yes. Enter. Okay. Why is it doing that? What's happening? Feature print. Print. You're gonna print. Can you hear it? So do print. It's gonna be a string and it's gonna be growing the tree. Next line, you're gonna do tree equals decision tree. DECIS. DECIS. Oh yeah. Tree. Enter. I mean dot. Dot build underscore tree. Build tree, and then function. That's a function, so circle bracket. You're gonna input training data. Training data. Next line, you're gonna do print underscore tree. Print underscore tree.
Your audio is unclear.
My bad. I don't know how to fix it.
Can't hear you that clearly.
Okay. Let me close my windows, see if that helps. Is this better?
Maybe.
Okay. Yeah, print tree, and that's a function. We want to pass in tree, comma, feature names equals feature headers. Or actually feature header. Yep. Enter next line. Mystery animal equals a list, so square bracket, or that works too. Up to you. You're gonna do okay. Delete the list, and I'll actually copy and paste this because it would be better that way. Next line. You're gonna do. Let's just do raw prediction. Raw underscore prediction equals classify, and that's a function. You're gonna do mystery underscore animal, comma, tree. Next line, enter. Named prediction. Name the prediction. NAMED. Named. Can you not hear me? Or is my audio cutting out?
What?
Named. NAMED.
What did you say?
Is my audio cutting out?
Maybe, I think.
Okay. NAMED. Or just do prediction. So prediction equals not equals, and then it's going to be a list. So a square bracket inside is going to be all caps class underscore mapping. Mapping, bing, PPING. Dot get dot 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 get. No, previous line. So delete the get. Go to class mapping. And then do dot get function. So dot get a period. So instead of the comma space, you're going to do a period. Yes, yes. Okay. Inside the get function is going to be k comma k or key comma key comma key, and then right. You're going to do for. No, for loop for. No, inline. You're going to do an inline for loop, so delete the for and then put it right next to the key. Yes. For key in, for key in, key,
I can't hear.
KEY. 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 For key. For key in raw prediction. Raw prediction. Raw. RAW. Can you see the line 48? We had our variable name, right? No. Reread the line 48. Hmm. No. Delete. We already said it, right? We can just use that variable. No, delete. Delete the raw prediction. Look at the line 48. Where do you think we went wrong? We only want the variable, right? Yes. And then you want to close that or do dot keys. So delete that circle bracket. Delete the circle bracket. Dot keys. That's a function, right? And then do closing square bracket. only the closing. Yes. Okay. Now we want to print to the user. So it's going to be, no, just print. That's not valid syntax. So it's going to be an F string. No, delete the to the user. It's going to be an F string, so it has to be F before the quotation. Yes. Inside it's going to be AI classification. Quotation. Colon, space, square bracket, curly bracket, prediction. And that's it. You can stop sharing. Okay, can everyone else hear me right? Or are you guys also seeing the same issue with not hearing me right? You're all good, okay. Where were we? Right, okay. Let me show. So that's it for this project. Um, okay, let me copy the solution over to solution. So git add solution, commit, message, finished, project 12, git push. Now let's also run to see what it looks like at the end. Okay. We see fetching the zoo dataset. We grow the wisdom tree. This is the visualization where is milk? Yes. Then it's a mammal. No. Then does it have legs? Yes. Then it's a bird. No. Then it keeps on going, right? Now we set a classification, which is our mystery animal, and we set out all these list of zeros and ones, right? And this classifies as a reptile. Now let's see what everything corresponds to. So from left to right, it's hair, feathers, eggs, etc. 0 means it doesn't have it. 1 means it does have it. So it has no hair. It does have feathers. Is this right? Oh yeah. It has eggs. It doesn't have milk. It's not airborne. It is aquatic. It is a predator. And it is tooth. It doesn't have teeth. Okay. But this is only because our class mapping, we only had 7 options. Of course, you can't fit the whole animal kingdom into 7 options. But you guys get the idea. Now let's also commit project 12 code in class. Sync changes. Okay. Now we're on to project 13. Okay. So now I wanted to do more than just a couple of Python files, right, guys? All we've ever done is small main.py, small AI training, etc. Now let's kind of move towards project-wise, a bigger project. So things like analyzing stock data. So do you guys know what the stock market is? Does everyone know what stock trading or the market is? Or have an idea about it? What does YH mean? Is it like, are you just saying yeah, but mistyped? Maybe I'm too old now. No, short form. What is it short form for? For, yeah. Oh, okay, I see. Okay. You learn every day, I guess. But yeah. Does everyone know what the stock market is? Yes. Okay. Basically, there's something called trading where you invest in something, a company, and yeah, things like that. Now, there's also something called uh something big in the stock market called analysis. So predicting whether a stock will go up or down or etc. And what we're gonna build is trying to build some kind of analysis for the stock market, such as fundamentals, portfolios, some risk management, and some technical details like some of these computations that you guys will see in like Y Finance, etc., right? So if there's like RSI is RSI stock market. You guys can see, right? RSI, which is relative strength index. But these are things like are formulas for the stock market to kind of determine where it will be headed in the future. So we'll just go through these. So this will be a bigger project. And secondhand, it also creates PDFs for the reports. So kind of summarizing everything that we do. Okay. Now let's read the README. So this is called a markdown file. So MD, which is markdown. You guys will read the preview, which is so markdown is the code. This is like the web view or the real view. Okay. So basically, it's a stock analysis tool with AI capabilities. We're going to do some price prediction, new sentiment analysis. So AI for sentiment analysis, like we did before, right? We did like the movie thing, but that's way lower tier since we only trained on like 10 data, which is too little. Anyways, technical indicators, so like the RSI, we're going to do some portfolio optimization, etc. So requirements.txt. So if you guys don't know what this is, so Python needs a lot of importing some external libraries, right? So usually you want to create a virtual environment, but if you do that, you're going to want to install everything from scratch, right? Since if you just create it, then that virtual environment Python executable wouldn't have anything downloaded. So you have to download everything back again. Well, requirements.txt is it's kind of like tells you what is needed for this project. So how you create it is you do pip freeze requirements.txt. It creates a requirements.txt with your current Python executable. So it kind of lists down everything installed in your Python environment at the moment. So if I share my code to you, all you need to do is create a new virtual environment and run pip install -r requirements.txt, and it will download everything. But yeah, that's exactly what it is. So why this is useful, as I said, when I share things with you guys, if you guys go on to bigger projects like in work, then all you need to do as a new hire or new intern or whatever, you just pull in the git pull or git clone the repository, and you do git Python VMV. So creating a new virtual environment. You do pip install requirements.txt to download all the necessary Python installations, and then you run it, right? Another thing it's useful in is for Docker environments. So if you guys create Docker containers, like at work, you guys usually do like virtual environments or you guys manage VMs for your Linux distros. Say you have a Windows computer, but you need something on the Linux side, then you spin up a Linux VM and work through there. Another thing there is you can just run pip install requirements.txt, right? Okay. Anyways, the 6 commands are an analyze. It's gonna do a technical and fundamental and risk analysis. Predict, you're gonna try and predict whether Apple or like the price prediction of Apple in a few days using neural network. I don't need to explain these, right? Since you guys already know what a neural network is, you guys already did it. Let me know if you guys have any questions though, midway. Sentiment analysis, also something we did, right? We're gonna analyze a newsletter headline. We're gonna see, okay, is this a good sign or a bad sign for Apple? AAPL is Apple. Optimize, we're gonna optimize our portfolio. Portfolio means like, say you have a folder and you have a whole bunch of stocks. That folder full of stocks is kind of like the portfolio. So the things you own. Correlate, we're going to do some correlation and heat mapping. Correlation is kind of like, say you're in a study and you want to find out the correlation between taking a vaccine and preventing a cold. Then you would find out it's like near 1-to-1 ratio. So that means most of the time doing a vaccine does help with preventing a cold, say something like that. That's what the correlation is. Heat map is like, how do you explain this? What sectors are doing better off than others? So like the tech is doing better than the healthcare side, etc. Report, as I said, it creates a PDF report of the analysis. For this, we need API keys. Do you guys know what an API is? Does anyone know what an API is? Nobody knows? Okay. Um, let's show you a quick video on API. When you connect to some system or something, like Discord API is used for me to code and run Discord bots. Yeah, so I think what you're saying is Discord provides an API for you to use. So some things like softwares or some website or some, I don't know, software that people can use, usually provide something called an API. API is for others to use as kind of like a communication tool between you and that software. So it's basically people say, think of API as a butler or a waitress in a restaurant. It basically just gives what the person wants, and that server goes to the kitchen, gets the data that the user wants, and then gives it back, kind of like that. So it's kind of like the middle between you and the software that you're trying to get access to. Share my screen. Share sound. Okay. Let me know if you guys can't hear it. We'll just watch like 1 minute or two.
An application programming interface, or API, is a way for two computers to talk to each other. Using an API is just like using a website in your browser, but instead of clicking buttons and filling out forms, you write code to explicitly request data from a server. For example, we could visit the NASA website to look at asteroids, or we could use their REST API to request the raw JSON data that is shown on the screen. Now, most APIs in the world are RESTful, which means they follow a set of rules or constraints known as representational state transfer, which has been the de facto standard for API development since the early 2000s. A RESTful API organizes data entities or resources into a bunch of unique URLs. Well, technically not URLs, but URIs, or Uniform Resource Identifiers, that differentiate different types of data resources on a server.
So this is the network location. So say you're getting it from discord.com. This is what you're trying to get. Like I said, the user requests something and the server gets it, right? So this is what we're requesting. So for Discord, it would be like some message. Then you would do /message or something.
A client can get data about a resource by making a request to that endpoint over HTTP. The request message has a very specific format. Most importantly, the start line contains the URI that you wish to access, which is preceded by an HTTP verb or request method, which signal your intent with the resource. A GET request means you just want to read the data, while POST means you want to create a new resource. Patch is for updates, delete is for removing data, along with a few other methods beyond those. Below the start line, we have headers, which contain metadata about the request. The accept header can tell the server you want the data in a specific format, or the authorization header can be used to tell the server that you're actually allowed to make that request. Then following the headers, we have the body, which contains a custom payload of data. The server will receive the request message, then execute some code, usually to read from a database, that can then be formatted into a response message. The top of the message contains a status code to tell the client what happened to their request. Codes at the 200 level mean that things went well. At the 400 level, it means something was wrong with your request. And at the 500 level, it means that the server failed. After the status code, we then have...
I'll stop here. But yeah, this is where you're getting the 404 errors. If you guys know what that is. So like, when you guys open up a website and it says 404, that's at this level. That's where the status code 400s are. Anyways, this is pretty important because this is used like everywhere. So on the web interface or websites, they're used everywhere, like going from backend to the front end, actually backend to the server. So say a website requests something from the server, then it uses an API. Even non-software or non-typical software systems like embedded systems, you still have it. Say some hardware is talking to some other thing that is also using a API, etc. Let me project 13. Let's share my screen. But yeah, we're using three APIs. FinHub for real-time news and finance data. FMP, which is financial modeling prep for fundamental metrics, and News API for business headlines. News headlines. Okay, so what these folders are like. So utils are like helpers. So utilities. So it says, right, small utility functions used across the project. These inits you guys can just ignore. We have the data client. So this is how we get all our datas. So this is where we call these APIs. Main.py, basically where we jot down all the commands that we can run. You guys can see these parsers. We have the predict, we have the sentiment, we have the optimize, etc. We're specifying, okay, this ticker, or we want to do this PDF, we want to do PDF, or like reporting, etc. Requirements.txt. So these are our requirements. So when you guys do this, you guys will do Python then. Yep. Okay. So let's see. CD code. No. Has oops. Okay, and then you do VMV. So you do Python dash M VMV VMV. VMV means virtual environment. The reason my Python's all like this is because I'm on Mac, and Mac has some weird Python stuff that you guys don't need to get into. Who knows this? No. And then we do activate. So this will be the programs. Let's project 13. Because we don't have a dot here. So we do this. Now we're accessing that virtual environment. Now we want to do what that README tells us to do, which is pip install requirements.txt. You see us doing this thing. Wait, before. You guys can see that yellow stuff, right? It's saying that we don't have it installed. Now we're installing it, right? So in a bit, you guys will see that yellow turn into just white, like this, OS. The OS is pre-installed and everything, so just wait a bit. You see it's installing Torch, which is PyTorch, which you guys should know that it's for training AI. While we wait, we have a separate reports folder for PDF reporting and terminal. You guys can see it's done. So if I reload this, probably it will be back up. And on the right one. No. Where is my virtual environment? Project 13. Oh, I went the wrong one. Okay. Open. Okay. Anyways, the reason is because This is the code folder. I put it in the test folder. So it's not being able to find it. It's right here. Anyways, why is it doing that? Anyways. Report model. So this is where we create our PyTorch model, neural network. This is for sentiment analysis. So we have a whole dictionary full of sentiments. So look through these, check if it's a negative word, booster word, or a good word. Data, there's nothing right now since there's no data. Correlation, fundamental, portfolio risk, technical. This is what I told you guys about. So it's the technical analysis, so the RSI, etc. So let's get started. I think we should start at data client. I think this is the best place to start. So when you guys do this, it'll be our student template this here. This one provides functions that fetch data from YFinance, FinHub, FMP, and Use API. So this is what I said. We're calling the APIs using the four methods, which are what you guys saw in the Fireshift video, which is put, get, post, and delete, I think. Yeah. Anyways, put is kind of like update, so we don't really need it since we're gonna do is get requests. So let's start here. So Adam went, Albert went, Charlotte went, Caden. Can you share your screen? Oh, wait. Let me share you guys Project 13. Actually, before we even start this, I think it's time that we do Git, or else this big project would be a nightmare. Do you guys have Git installed? All 7 of you? Tell me if you guys don't have it installed. Okay, Git, download. Charlie, do you, okay, actually, this is the link. So if you don't know, go to the terminal. So James, can you share your screen? You're gonna want to go to terminal, open it up, and then share your screen to that terminal. Or unless you want to just share your whole screen. Those of you who know you don't have it, go to this link and then download it. Only if you have Windows. This is probably the function. Which one do you do? Okay, so there's by which one do you mean for Windows, Mac OS, or Linux, or you know yours is Windows. Is your computer Windows? Oh, okay. So do you know if your system is x64 or ARM 64? Yours is probably x64 though. So ARM 60. So what these are compiling base or like assembly level or ISA level uh, instruction set architecture. So ISA level. So basically, the different types of CPUs have different set of instruction level architecture. So if you have an ARM CPU, then it's different from a x64 CPU. So it's things like that. So you're gonna want to go to settings. Go to system and about. Go down all the way down about. So everyone do the same thing. Go to system about. You guys will see, okay, you have an Intel CPU and it says system type is X64. So you want to do the X64. Yep. And you have a 64-bit computer. You have X64. Okay, then do the standalone installer for Git for Windows x64 setup. That's what you want to do. But yeah, so you guys will learn this later, but basically, Charlie, does the Git version work on yours? If it does, then it means you have it. So Git dash dash version. This one. Try this on your terminal, and then it'll see if it says Git version blah blah blah. If it says Git not found, then you don't have it. Just finish it. It's just download the. So you want to run the exe file. And Charlie, you can share your screen now. James or who shared this. Okay, James was sharing. Okay. So Nicholas, you're gonna wanna double click the exe file to run it. Caden, you wanna run that command that I just gave in the chat. It's git dash dash version. How do I know what git I have? Or do you mean what you wanna install? Oh, what you wanna install? You wanna go to, do you have a Windows computer? If you do, go to settings. Settings, system, and about. Okay, who else asked? Charlie. It didn't open. Oh, is it still downloading? Okay, Nicholas, share your screen. Yeah, but you don't know if you. Oh, you did install. What?
Like it's here. Just
Okay,
I
wait.
click
Nicholas first.
I just click
Uh,
no to make changes.
can you go to the where it says recently downloaded history and then open the folder? Like the file location. Yeah, that one. That one's good too. Did it show anything? I can only see your
Yeah, it just shows
double.
the
Can you
download.
double click it? It should
Do I
give you
let,
like a pop-up.
yeah, should I let it make changes or not?
Yes, yes. Yeah. It won't be harmful because you got it from Git.
You know, it's doing something.
Okay, so you're good now. Who else? Charlie. Should I just be mindlessly clicking next repeatedly? Yes, yes. It's pretty fine to just go by default settings. Okay, I think I installed it. Okay. And okay, so Liam has it. Albert has it. Charlie is installed it. Adam, I don't think Adam has permissions. James has it. Hayden has it. Okay, wait. Caden, you don't know if you installed. Can you share your screen? Or did you get it to work? Or okay, that's good. I give you the Windows version. That's good. I mean the Git version. So now is the harder part where we try to give you guys access to your. Oh wait, do you guys have GitHub? So do you guys have a GitHub account? Maybe. Okay. Um, yeah, go check and let me know if you don't have it. Yeah. You can stop sharing your screen, kid. If you don't have it, make it. I don't think it'll take too long. But yeah, make it, and then we'll also do on this. Okay. Which of the components should be installed? That's good. You can just click next. So Nicholas, you can click next or accept whatever that check marks. They're already check marked. And Caden, if you can make a GitHub account. Mm. And then we'll talk about how SSHing work, but I can't log in. You have to make a new account, I think, right? So you don't have an account. Oh, you did, but like, are you able to do two-step verification? Or is your problem that you can't? You forgot your. Can't you retry resend? Resend code? I'm pretty sure two steps. Okay, and then Windows Web. Okay, to reset it. Give me a minute. Never mind, it takes a whole day to reset. What? Wait, what's two-step here? Are you doing like the... Okay. Okay. Then Kaden, maybe we'll just have to wait tomorrow or something. But yeah, Nicholas. Who else doesn't have an account? Nicholas doesn't have an account. Can I use Visual Studio Code? Liam, I think you should go for Vim. Does this say Vim by default? Yeah? I think you should go for Vim. Yeah. That's a good question, though. You just mindlessly clicked. Yes, that's what I do too. Okay. Now, Nicholas, did you create a new GitHub account? I think that's the next step. I don't think that should take that long. Let me know when you guys are done, and then we'll do SSH key creating. It brought me to this page. Oh, you made the GitHub account. Eh? Oh, wrong one. Okay. Oh, I'm confused.